Okay, record the meeting. Okay, so we start now. Uh, so the first thing is we want to talk about is uniform and non-uniform. So for examples, we check this. Okay, so what is a non-uniform? The non-uniform, it means that the x coordinates is not uniform. So it means that your S0 is 0, and then S1 is 0.6, and then S2 is 0.9. So the difference is 0.6. The difference is 0.3. So they are different. So this we call it non-uniform data. So it means that when the data, the S coordinates and the input is non-uniform, then we can using Lagrange interpolations. But Lagrange interpolation also can use for uniform. So it means that when the Lagrange interpolation is applied for non-uniform, then the uniform they also can be used Lagrange interpolations. For example, if your S0 equal to 0, S1 equal to 0.5, S2 equal to 1. So you see the increments delta x equal to 0.5, and then the delta x equal to 0.5. So this kind of data we call it uniform data. Then uniform data also can apply Lagrange interpolations, because Lagrange interpolation is very flexible. It can apply for non-uniform. Non-uniform, it means that your input is non-uniform. The increment are different, you see, 0.6, 0.3. So increment are different, then we call it non-uniform. So once Lagrange can apply for non-uniform, then uniform should be no problem. Everyone clear? So now we go to the second. Newton divided difference. Newton divided difference also apply for non-uniform data. It means that your S increment are different. So, for example, the first S0, S1, S2, S3. So this is a S0, this is S1, S1. So what is the increment? The increment is H equal to 0, 0.1. The increment is 1. And then from 0 to 1, the increment is also 1. But from 1 to 3, the increment is 2. So different increments. So this we call it non-uniform data. So Newton divided difference can be applied for non-uniform data. So this is a non-uniform data. So once they can apply for non-uniform data, then the uniform data also should be no problem. So it means that if your S increment are same, then also can apply, because the Newton divided they can apply for non-uniform. So it means a very complicated data it can apply. Then the simple data, it means uniform data should be no problem. So this is a solution. So we found that this is a f0, this is f superscript 1, this is a function superscript 2, this is a function superscript 3. So this is a polynomial because we have how many data? 1, 2, 3, 4. 4 data. 4 data, it means that your polynomial must be power 3. What is power 3? A0 plus A1s plus A2s squared plus A3s cubed. So how many unknown? A0, A1, A2, A3. So 4 unknown. And then we've got 4 data, 4 input, 4 information. So it's matching together. So in other words, the actual polynomial passing through the 4 data supposed to be power 3. So that's why this Newton divided difference initially is P3, power 3. So until F superscript 3, you see this S. So this term is S power 3. So it's cubic, power 3. But we found that the f superscript 3 is 0, you see? It's a 3, 0. So we found that this one will disappear. So that you only have 1, 2, 3. Only 3 values. So it means that your polynomial become polynomial 2. So the first is f00 is this. So it's 4. And then the second is f01. 01 is here. So it's minus 5. Minus 5. S minus, what is S0? Initial value. So it's minus 1. So it's minus 1. And then plus. So F02. F02 is here because this index 0. So this is 02. So it's 2. So plus 2. And then you get S minus 0, S minus 1. So S minus minus 1. And then S minus S1 is 0. 0. So you found that this is polynomial 2. So it's 4 minus 5s plus 1. And then this one will be plus 2s s plus 1. You see, this is a quadratic s power 2. So when you simplify it, then you get this actual function. So in the exam, sometimes we didn't give you the actual functions. So you simplify, then you get back the actual functions. So from here we found that this is degree 2, degree 2, power is a power 2, maximum is power 2. So it means that this is s power 2. So this one, this is polynomial quadratic. So degree 2. So you want to approximate 1, it means that you put the s equal to 1, then you get the answer. Or you want to differentiate. It means that you differentiate this. Actually, this one, when you simplify, then you get 2s cubed square minus 3s minus 1. So this is a polynomial 2. After you simplify, so you want to calculate this, then you differentiate polynomial 2. So after you differentiate, you got 4x minus 3. So you substitute 1 inside. S equal to 1. S equal to 1 inside, then you get 4 minus 3, so equal to 1. So the gradient is 1. So everyone clear? So any questions? Check. Is there any check? If you have any question, you can write in the chat. So you can check the chat and then you write something in the chat. And also make sure that your e-learning is accessible. So I think before we continue, we try to take a snapshot. Let me see. So until now, it's still 49. 49 students attending the class. Okay, everyone, please open your cameras. I want to have a snapshot.
Sorry, doctor. My camera is not functioning.
No function, it's okay. Okay, smiles. 1, 2, 3. Oh, those. Okay. Open your camera. Smiles. 1, 2, 3. The last one. Oh, 1, 2, 3, smiles. Okay, thank you everyone. So we will stop the videos. We will continue, sir. So another ones. So oh yeah, please scan the QR code for those who know how to scan. Or you can scan through the WhatsApp. I already shared in the WhatsApp group. Okay, so now we continue again. So this is the Newton divided difference. So now we move to the third method, that is Newton forward difference. Slightly similar with Newton divided, but this data is uniform data. So I want to highlight here is uniform. So if, for example, if given the questions, example, the question is open question, you can use any methods, but the data is non-uniform, then you cannot use in the forward difference. So because the forward difference is uniform data. So if the S is with a different increment, so we call it non-uniform data, then you cannot use in the Newton forward, but you can use in Lagrange or Newton divided. Okay. So now what is Newton forward difference? They assume that the data is uniform. Uniform, it means that S0, S1, S2, S3. So this is increment H. Okay. So in other words, S1 equal to S0 plus H. So S2 equal to S1 plus H. So S2 equal to S1 plus H. They equal to S0 plus 2H. So S3 equal to S0 plus 3H. So S3, so 1, 2, 3, 3H start from S0. S0 is initial value. So the function function is data lah, input data lah. So this is function input data. So in the exam, normally we will give you the polynomial, or sometimes we didn't give you the polynomial. So this, we assume that this is experiment data. This is experiment data. We assume that this is experiment data. So F0 for S0. Function 1 is for S1. Function 2 is for S2. Function 3 is for S3. So for this case, you see, our S is uniform. This is 1, 1.5, 2, 2.5. Okay, you see here? This is a uniform. So this is S0, this is S1, this is S2, and this is S3. So from here to here is increment 0.5. So from here to here, increment 0.5. So from here to here, increment 0.5. So H is increment. H, the H is increment. So H is equal to the increment delta X. Okay. Now, for this Newton forward difference, this is a formula. The polynomials can be represented by F0. F0 is initial data lah. Then delta lah, this is delta F0, and then delta power 2 F0, delta power 3 F0. So this is a formula. And then we found that this is R. What is the R? The R is the integer values. For example, we have the look on this. Okay, so it means that your X is equal to S0 plus RH. S0 is this value, initial value. So we found that. So this S actually is equal to the S0 plus RH. So R is integers. So for example, S1 equal to S0 plus 1H. S2 equal to S0 plus 2H. So for this case, R is equal to 2. So S3 equal to S0 plus 3H. So your R is 3. So this is R. R can be integers. So in other words, we check from here. So this is S0. This is a function 0. This is a function 1. So here, it means for this case, R is 0. At S1.5, R is equal to 1. Why? Because you can check from here. You can check from here. So now, I try to erase this. Okay. We check from here. So S equal to what is S0? S0 is 1. S0 is 1. 1. What is a H? H increment is 0.5. So 0.5 R. This is so now 1.5. What is 1.5? Actually is equal to the S1. So when the S1 is equal to 1 plus 0.5, when R is 1, so you get 1.5. So 1.5 is here. So that's why for this coordinate S equal 1.5, your R is equal to 1. They are similar. R is equal to 1. And then when your S is 2, S is 2, S2 equal to 2, actually is equal to what? Actually is equal to 1 plus 0.5 times 2, times 2. So that you get 1 plus 1 equal to 2. So what is the R? R is equal to 2. So this one R is equal to 2. Here. 0, 1, 2 is here. R equal to 2. When R equal to 2, then your S is equal to 2. So your index is 2. Okay? You will get this. And then when S is what? 2.5, actually is equal to the S3. 2.5 actually is equal to the 1 plus 0.5 times 3. When 1 plus 0.5 times 3, then you get 2.5. So that's why, what is R? Your R is equal to 3. This is R equal to 3. So in other words, when the S is 1, your R is 0. When your S is 1.5, your R is 1. When your S is 2, your R is 2. When your S is 2.5, your R is 3. So based on what equation? Based on this equation. This is the equation. So everyone clear? So now we need to fill out this table. Almost similar like Newton dividers. So F0, F1, F2, F3 actually is this function. Is this function. So this function. So function S0 actually is equal to F0 lah. So equal to 1 is substitute inside this equation. So equal to 2, 1, power 2, minus 3, 1, and then minus 1. So what is the answer? The answer is minus 2 lah. So it's here. And then F1, what is F1? F1 equal to F S1. Okay, S1 inside. What is the S1? Your S1 is 1.5. So you get 2 multiplied 1.5 power 2 minus 3, 1.5 minus 1. So what is the answer? The answer is minus 1. So equal to minus 1. Minus 1. So equal to minus 1. And same thing. For the F2 is 1 is because you substitute 2. You substitute 2 inside this quadratic. Then you get 1. So F3 is you substitute 2.5 inside these equations, then you get 4. So this is explained data. So sometimes in the exam, we provide this function. Sometimes we didn't provide this function. We just give you this data. Everyone clear? Any questions? Actually, online teaching is difficult a bit, so we need your response, feedback. If you are not clear, then you let me know. That is important. I try to check in the Google chat and the chat. You can write your chat, write something in chat. If you have any problem. Okay, nobody writing in the chat. Okay, clear. Okay, then we continue. So now I want to show you how to calculate this. I'll show you this, and this question mark you need to calculate, like previous classes. So this one you need to calculate. This one you need to calculate. Okay, the first is I will show you how to calculate this. Okay, delta F0. So delta F0 is based on this. This is a formula. This formula. So delta F0 equal to, actually this is a 1. Delta 1 F0. 1, delta I mean delta 1. So then it's equal to 0. So it's equal to delta 0 F1 minus delta 0 F0. This 0. So delta 0, it means that it's equal to the F1 minus F0 lah. So F1 minus F0. So it's equal to -1 minus -2. So what is the answer? The answer is 1. So you get 1. So everyone clear? Okay, now I show you what is delta F1. Delta F1 is delta power 1. Delta and delta power are same, F1. So you substitute. Wait, this K is 1. What is I? I is 1. Substitute inside. Then you get delta 0 F2 minus delta 0 F1. So for this K is 1, this I is 1. Then you will get F2 minus F1. So what is F2? F2 is this 1. 1 minus F1 is -1. So you get 2 lah. So you get 2. So everyone clear? So later you calculate delta F2. What is this value? It's like pyramid, upper triangular. So this one no need calculate. No calculation, no calculation, no calculation, no calculation, and no calculation. Okay, after that, I will show you how to calculate this. This actually is equal to this. Delta 2 F0. Delta 2 F0. Then is equal to your K is 2 lah. Your K is 2. Your I is 0. So then become K minus 1. So it's equal to delta 1 F1 minus delta 1 F0. So what is delta 1 F1? Delta 1 F1 is here. Delta 1 F1 equal to 2 minus delta 1 F0. Delta 1 F0 equal to 1. So you get 1. So you get 1. So everyone clear? Then you try to answer this. What is this? And after that, you calculate this. Then you will get the whole equation here. So this is the equation. And you want to calculate 2.1. 2.1. So for the 2.1, so they are like this. So now once you get this f0 delta f0 delta power 2 f0 delta power 3 f0, then you can calculate this. You see, 1 2 3 4 terms. 1 2 3 4 terms. Then you need to change to the r. So now the question is f 2.1. What is the meaning? Meaning is that your s is 2.1. So you substitute inside here. So S equal to S0 plus RH. Then your S is 2.1. What is initial S? Initial S is 1. So this 1. So it's equal to 1. What is your H? H is increment 0.5. R. Yes. So we get this 2.1 equal to 1 plus 0.5 H. You will get this. You'll get this. You'll get this. And then what is your H? Then it's 2.1 minus 1 divided by 0.5. So you get 2.2. 2.2. So quite easy because we check the value. Okay. When the S is 1, the first value, then your R is 0. When the S is 1.5, your R is 1. When S is 2, then your R is 2. When S is 2.5, your R is 3 integer. Then now I want to calculate 2.1. 2.1, 2.1. Then must be near to 2, but more than 2 because 2.1. So that's why your R must be 2 point something. So that's why we get 2.2 lah. Okay, and it means that from here actually you know what is the range for your R. So because when the S is 1, your R is 0. Your S is 1.5, your R is 1. When your S is 2, your R is 2. When your S is 2.5, your R is 3. So I want to predict the value 2.1, a little bit higher than 2. So your R must be a little bit higher than 2. So that's why we get 2.2. So it means that you have these 4 terms, and then you substitute your R equal to 2.2. Okay, clear? So it means that when the polynomial S equal to 2.1, 2.1 actually equal to polynomial R equal to 2.2. This is R equal to 2.2. Hey, this is R. No. This is not the H. This is R. R. So this is R. R is 2.2. 2.2. And then you substitute R equal to 2.2 inside this R, and this R. And then you calculate, then you get the answer. Everyone clear? You do the exercise. So your first step is you need to fill out this, calculate this, and then you calculate this. 1, 2, 3, 3 terms. And after that, you write these equations. F0 R delta, F0 R minus 1, 2 factorial, R minus 1, R minus 2 over 3 factorial. Okay, you got 1, 2, 3, 4, 4 terms. Because 4 data, then you must have 4 terms. So this is a linear. This is quadratic because R square. This is a cubic R power 3. Okay, what happened to this gradients? The gradient is like this. To calculate the gradients, there's a little bit difficult. Based on the chain rules, you see, we know that S equal to S0 plus RH. So equal to S0 is equal to 1 plus, what is your H? 0.5 R. H is 0.5. So actually is this. So now I want to differentiate DDS equal to DDS S0 plus RH. So DS equal to 1. S0 is constant, is equal to 1. You differentiate, you get 0. Okay, RH, H is constant, so H will be moved out. Then we get dRds. So from here we get drds equal to 1 over h. So this is a chain rules. So I want to calculate f prime 2.1. Actually is what? Actually is equal to the d dx functions at s equal to 2.1. Now this will becomes d dr functions and then dr dx at r, because initially s is 2.1. When s is 2.1, then what's r? Your r is 2.2. So r is 2.2. 2.2. So because actually this the polynomial, if we follow the Newton divided, you see Newton divided. For the Newton divided, the polynomial is in terms of s. You see the s, then you can differentiate the s. But for the Newton forward difference, you don't have the s. You only have r. This is r. So you cannot differentiate on the s. So you must differentiate on the r. So become d dr. So this is a chain rule, d dr. Then you must multiply dr dx. So you see dr dr cancel, then you get dx. So what is dr dx? This is a dr dx, 1 over h dr dx. So in other words, you will get 1 over h. Dr dx is 1 over h. And then d dr functions at r equal to 2.2. So in other words, why you get the value here? So for example, your polynomial is equal to, what is your f0 is minus 2. And then what is delta f0 is 1. So plus r. And then what is this? Delta square f is 1. So you get plus 1. R minus 1 over 2 factorial, and then this is 1. So let's say this is a polynomial. Then you need to differentiate. Actually, this polynomial is equal to the function. Equal to the function. So you differentiate on the r. So it means that you differentiate on the r for this polynomial. For this polynomial. So you can differentiate. You differentiate it. So you get 0 plus 1 and then plus something. So you differentiate upon the r. And then this value multiply with 1 over h, because this is a chain rules. Once you get the value, then you substitute r equal to 2.2 inside. Then you get the gradients at 2.1. So A1 clear? So for this Newton forward difference, your first step is, after that you do the exercise, you create the table. This f function is data, experiment data, is come from this function. So you substitute the x inside, then you get a function data. Then you calculate the delta, power 1, power 2, power 3, based on this formula. Based on this formula. This formula. Once you get this, then your polynomial is this. This is a polynomial, you see. R1 multiply R minus 1 over 2 factorial. R minus 1 R minus 2 over 3 factorial. So this is a polynomial. So this one is quadratic. And when you want to calculate the values, for example, 2.1, actually initially is s equal to 2.1, but you must convert to the r, because the polynomial internal r, you see internal r, they are not internal s, they are r. So you calculate the r. What is r? 2.2. So it comes from here. 2, this is r. Sorry, h is 0.5, r. Then r is equal to, you minus divide, then you get 2.2. So you get 2.2. You substitute inside this r. Then you get the answer for function at x equal to 2.1. And this is gradients. The gradient is based on this formula. F prime equal to the d dx. Initially, they are differential on the x at s 2.1. Then we using the chain rules, become d dr. Multiply dr dx. You see, r cancel. So what is dr dx? This is a dr dx, 1 over h. You substitute inside, then 1 over h. Then you differentiate polynomial upon the r. So this polynomial, you differentiate upon the r. Then you multiply, and then you substitute r equal to 2.2 inside these equations. This equation. Then you get answer. So A1 Clear? So now do the exercise. Everyone do the exercise, and then once you get the answer, you snapshot your solutions, and then you post in the WhatsApp group. Clear? So after that, I waiting the result from your WhatsApp group. So try to solve it right in the papers, and once you get the result for these two, the first is you fill out these three values right in the tables. After that, you calculate for the function 2.1. Then you calculate the gradients at 2.1, and you show the step, and then you snapshot your photo, and then you share in the WhatsApp group. Then later I will discuss about the solution. Okay, clear? So you can do the exercise now. So I try to mute the So everyone, for those not yet scan your QR code, please scan your QR code. The attendance until now is only 52. More than 10 students didn't attend. You then scan the QR code. At the same time, you try to do the exercise. I'm waiting for the result. For those you have the result, then you snapshots, and then you share in the WhatsApp group. You share in the picture form is okay. Because we need to discuss about your solutions. So please scan the QR code. Uh, Nothing, Faiza, are you there? Nothing, Faiza, are you there?
Yes, doctor.
Okay. You still doing fill all the
Yes.
tables?
I'm still
Okay.
doing.
Still doing. If you manage to get the result, and then WhatsApp in the share your result in the WhatsApp group. Not in the meeting. Chiu Kai Bing, are you there?
Yes, doctor.
Do you manage to complete the tables?
Yes, the paper is already done. I'm doing the option B.
So you already get the polynomials. Do you able to calculate the solution at the 2.1?
Yes,
How about the derivative?
derivative is now calculating.
Now doing that. Okay. How about Faizul Iza? Are you there?
Yes, doctor.
Faizul, do you able to complete the table?
I'm still stuck.
Pardon?
I'm still stuck.
Oh, you know complete the table, okay.
Right.
You try to see my the what the formula the formula is this this is a formula this is a formula delta power k fi then is equal to the delta power k minus 1 delta power k minus 1 so this I will be I plus 1 minus I. You see the index, so follow exactly. So this is delta power 1 this is power 1 delta I mean power 1. This one is delta 0 power 0 delta power 0.
Think
Oh,
I key in wrong value just now. Okay. Wait.
pardon? Can you
I,
speak loudly?
I think I key in wrong value just now.
Oh, wrong value. Okay.
I'll try to check back.
This one must be 0. I tell you, this one must be 0. Because why? Why is 0? Because this is quadratic, power 2. So because this data is power 2. So when we reach to the power 3, this one must be 0. So delta power 3 must be 0. So this value must be 0.
Okay, this one must be 0. I think we had a solution. Let me see where is the solution. Ah, oh, Satya, thank you for your solutions. Hey, Satya, can you share your table? Do you share your table? Oh, this is a table. Oh, okay. This is a table, huh? Okay, we try to have a look. Really? Okay, this is a home loan. So we try to have a look. Mm. Eh, this is a this one. Okay. So this minus one, correct? Oh, too thick. Too thick. Let me see. Eh, how to increase this one, sickening. No, this one changed already. Oh, yeah, yeah. Okay. So this is given. Minus one is given. 1, 4. Okay. This is given 1, 2. Okay, now 3. 3 is equal to delta F2. Equal to, we follow this formula, this formula. So it's equal to delta 0 F3 minus delta 0 F2 equal to F3 minus F2. So F3 minus F2, so it's equal to the 4 minus 1, so equal to 3. Yes, correct. Quite simple. Okay, then we move to this. This is power 2 F0 F1. F1 equal to power 1 F2 minus power 1 F1. So then this is power 1 F2. So 2 minus power 1 F1. So 1. So 1. So we get 1. So you get 1. 1, 1. Then what is this? This is power 3 F0 is equal to power 2 F1 minus power 2 F0. Power 2. Power 2. 1, 1 minus 1. So equal to 1 minus 1. So you get 0. You get 0. So it's correct. So it means that this one must be 0. Must be 0. So 0. So that this part will be 0. Delta power 3 will be 0. So this is a quad. cubic, power 3 will disappear. Then you get power 2 only. Okay? So it's correct, Satya? Let me see. Okay. Now we get the value. So substitute inside here. Ah. Okay. So you see, this is a power 3. Power 3. So this is 0. So disappear. So we only have linear terms, constant, linear terms, and quadratics. Quadratic. Oh, you substitute this inside. Actually, it's okay. You want to substitute the because this f. Okay, what is r? Because it's like this. S equal to S0 plus RH. So equal to what's S0? S0 is 1. Okay, we see here. S0 is 1, so it's 1 plus. What is R? R is R. What is H? H is 0.5. So 0.5 R equal to 0.5 R equal to S minus 1. So what is R? 2. S minus 2. Actually is equal to 2 S minus 1. Can. Actually, you can change from R to S. It's okay. So R you change to the 2 bracket S minus 1. Because S minus 1 multiply this half, move to the right side become multiply 2. So that's why you get 2 multiply S minus 1. Actually, this is R. Yeah, okay. Okay, good. So this is equal to the R. And this is R minus 1. So we can 2 S minus 1, this is R. Then R minus 1 over 2 factorial multiply 1. It's okay. You can using this. Or you can straight using the R. Actually, both came. Both came. But then, you simplify. Finally, you get this. But you know you answer the question. The question is, what is the solution? The solution, no, yeah, answer it. Yeah? I think this one okay. This one quite good. This one quite good. It's okay. This one answer is F0. Okay, correct. It's correct. Okay. But no, yeah, answer here. I want the solution for this. The solution for this. It means I want the solution for when the S is 2.1. What is the answer? And then 2.1 you differentiate. Okay. So just check. Chiu Kai Bing, are you there?
Yes, sir.
Chiu Kai Bing?
Yes, sir.
Do you manage to calculate the answer at 2.1?
Yes, I post in the group
And how
already.
about the gradients? F prime at 2.1?
Yeah, I also done already.
Yeah. So if like this, then you share your result in the WhatsApp group. So we need to discuss about the result.
Okay, I share already.
Okay, good. We try to have a look. Oh, this is a gradient. Oh, okay. Later. Then this one. Okay. What is the answer? Oh, okay, this. So the answer is this, eh? Hmm. So, okay. So this is the answer. Okay, this is a polymer. Yes, correct. So S equal to S0 plus RH, okay? And then S is 2.1, so S0 is 1, so H is 0.5 R. So what is R? R is 2 by 2, yes, correct. So you substitute your R 2 by 2 inside here. So this is a polymer of R. And this is polymer of R. So you substitute inside. Then you get minus 2, and R is 2 by 2, correct? And then this one is 2 by 2 minus 2 factorial. And then this is a 2 by 2. And finally you get 1.608. 1.608, let me see. 2.1, just a minute. I check the solution. 2.1. This is the Newton forward difference, or 2.1. Oh, the answer is 1.52. 1.52. The answer suppose is 1.52. Because you see the polynomial, the polynomial is x equal to 2s power 2 minus 3s minus 1. So I put f 2.1, 2.1, this f 2.1, then I get 2.1 power 2 minus 3, 2.1 minus 1. So let me see. So it means that my f is 2 times x power 2 minus 3 times x minus 1. So my function 2.1. 1.52, it's wrong, 1.52. 1.52. So it means that something will be mistake here. 3 factorial, this one should be 6, equal to 6. This one minus 2, 2 by 2, yeah, correct. 2 by 2, multiply 2 by 2 minus 1 is correct. 2 by 2, 2 by 2 minus 1, 2 by 2 minus 2, yeah, is correct. Over 3 factorial is 6. But you calculate, the answer is not this. The answer is 1.52. Okay? Clear, everyone? I think the calculation wrong. You have to do the sum calculation again. The answer is 1.52. How about the others? Oh, okay. The other get 1.52. Yes, correct. But anyway, Chu, that is a good try. Okay, we see the gradients. You check for the gradients. The gradient. Oh, 5.4. Okay, check. Okay, now we check for this. Okay, you see, okay, this is a formula. And then equal to this. R minus 2. This one R minus 2 over 6. Correct. 8. Suppose this is 0. 8. This one is 0. Don't have this. Oh, because they multiply with this. So, okay, this is 1, 1. This one 1. So it's here. So it's 1. And then this one also delta power 2, 1. But this power 3 is 0. So this one 0. No more this. No more this. So only have this. Correct. This one is correct. Right, this one is correct. But this we don't have this. Don't have this. Only this. Okay. So minus R over 2. Okay lah. So minus R over 2. So minus 2. This one is R over 2. This is R. So R minus R over 2. Then suppose is R over 2. So this is half. Half. And then this is A. This one don't have. So this one is R over 2 over 2. So this one is R over 2 over 2. This is wrong. So when you differentiate, df dr is equal to half R, half, you get R plus this one you differentiate, then you get R. You get this. And then it's here. Yeah, it's correct. This then is equal to df dr ds. R equal to 2.2. Yes, correct. So equal to this. Function is differentiate on the R, and then this one is 1 over h. And then R equal to this. So 1 over h is this, correct? And then let me see. What is this? This one is wrong. Suppose it's this. Suppose it's suppose it's this. Half plus R. So it means that it must equal to this is half plus R. And then divided by 1 over h. So it's equal to 2. And then what's R? Your R is 2 by 2. So finally you get 2 by 2 plus 0.5 over 2 multiply 2, so you get what 2 by 2 plus 5, 2.7 by 2, so you get 5.4. 5.4. I saw some people get answer 5.4. Where? Oh, yeah, 5.4. 5.4. Yes. Anand Sami, you get 5.4. So it means the answer is 5.4. 5.4, So check the answer here again. 5.4. So actually, so it means that when you get the R and then you differentiate. So basically like this. So this is probably the function in terms of R. So that's why you multiply on the R. And after that, you multiply DRDS. So this DRDS is equal to this. DRDS is equal to 1 over H. So equal to 2 lah. So you multiply with this. And then you need to change to R. So it means that when your X is equal to 2.1, then your R is equal to 2.2. You just substitute inside the R. This one is wrong. You need to use this. Because this part is 0. Is 0. So you substitute inside, then you get 5.4. So, or you can check with your solutions. Your solutions. This is the solutions. Okay, you can check the solutions because your polynomial is equal to this 2x squared minus 3x minus 1 after you simplify. So df dx. So in this one without changing to the r, so you get 4x minus 3. So df dx, when s is 2.1, then you substitute 4 2.1 minus 3, so you get 5.4. Okay, clear. Any question on this part? Any questions? No questions, Okay, no questions. Okay, this material I already post in the e-learnings. So this is another materials, Newton power difference. So everyone's try to do this exercise. How to do this exercise? Okay, try this exercise. And share your solutions in WhatsApp group. Okay, this is a quite good problem, sir. So this one I will snapshot the e-learnings. Okay, so now we still have some time, so I want to do some revisions on your divisions or nonlinear equations before your quiz one. Okay. So they have a few techniques. So one is the intermediate value theorems, and then the second is the bisection methods. Okay, maybe I discuss about what is bisection methods. So these are revisions before you start with your quiz. Quiz one. So this is the bisection methods. So what is the questions? The question is, okay, Fs equal to S power 3 minus S power 2 minus 2. Okay, this is a question. So I put in the question here. Okay, now I start with A0 and B0. So A0 and B0, so it means that it's like this. So it's X. So A0 and then B0. So A0 is 1. B0 is 2. A0 and B0, 1, 2. So you substitute A0, this is S. S. This is X. 1. Inside these functions. Then you get minus 2. So what is the meaning? It means that this is your y. So your solution at here, minus 2. Minus 2, minus 2, solution here. And then your b is, where is your FB? How come don't have FB? I show the FB. So F. Power 3 minus S power 2 minus 2. Okay. So FB is 2. You get 2. Okay. 2. So FB0 equal to F2 equal to 2. 2. So it means that B0, then your F will be 2 here. 2 here. So it means that your solutions, because this is a function. So when your S is 0, then you get minus 2. And then your S is B0, 2, then your answer is 2. So 2 value here. So from here, we found that we have C0. What is a C0? C0 is a middle. C0 is the middle between A0 plus B0. So it's 2. So you get 1 plus 2 over 2, you get 1.5. So 1.5 here. And then 1.5 is this, negative 0.8. So what is negative 0.8? It's here. It's here. So C0 at the middle. And then what is the answer? Your answer at the bottom is here. So I repeat here again. For the A0, S your 1, then what is the answer? Your answer is minus 2. So this is a point. When your S is B0 is 2, then what is the answer? Your answer is 2. So this is the answer here. When your C0, S is 1.5, then what is your solution? Your solution is negative 0.8 is negative here. So it means that for this coordinate, your answer is here. For this coordinate, your answer is here. For this coordinate, your answer is here. So then we plot the graph. So this is our solution graph. Then we plot our graph. Our graph is like this. This is a graph. So this is a graph. This graph will passing through this point, this point, this point. So this is our solution. This is our function. And then what is your root? This is your root. Because you see this is negative. This is negative. This is a positive. So these two negative, so it means inside here, inside this range, this domain, no roots, no solution, no intersect with this x-axis, because both are negative. But for the second region, this is a negative, this is a positive. So for the negative to the positive, there must be a line passing through the point. So what is this point? This point is a root. So this one, your roots is in 1.5 to 2. Okay, your root is in 1.5 to 2. Your root is not in 1 to 1.5. So your root is not in 1 to 1.5. So your root must be 1.5 to 2. Because why? Because this is a 1. This is 1.5. This is a 2. So where is the root? Your root must be here. Must be here. So this one, we go to our second iteration. So where is our second iteration? Our second iteration will be like this. Initially, we start from 1, 2, but now no more. This is a 1, this is a 2, but now we take half. We are not talking about this, we are talking about 1.5 to 2. Now this 2. Because here, 1 to 1.5, no roots. The root is 1.5 to 2. So we taking this region. So initially is 1 to 2. 1 to 2 is very, very big. You see, 1 to 2, from 1 to 2. But now we only half. So this point will becomes A1. This point becomes B1. Initially, A1 is 1. B0 is 2. So it means that initially, A0, B0 is equal to 1 and 2. Because there's a root between 1 and 2. But now we found that the root must be 1.5 to 2. So that's why after that we improve. Now our A1 and B1 will becomes a 1.5 to 2. So we have the domain. You see the domain we have it 1.5 to 2. So my left side is still A, but we call it A1. We increase the index. My right hand side, this is left hand side. Right hand side is B, but initially is B0, now become B1. So we found that when the index increase, their width, it means their domain becomes smaller and smaller. I mean smaller and narrow down. So when we go more step, and then these two become very close to each other. Very close to each other. So this